In this video I'm going to explain about where the standard deviation formula comes from and how it works. Okay, this is the first part. In the second part we're going to think about why we don't use the easy to understand formula, we use the other formula for calculating. Okay, so in your formula booklet you get all four formulae for the standard deviation. The top row is for a list of data, which we'll focus on just now. The bottom row is for like a frequency table, hence the frequencies. And notice if you add up the frequencies, you get how many data points there are, n. So in this formula, the x represents a single data point, and the x bar represents the mean of the data, okay? And the n is how many data there are. F represents frequency. We've got sigma, which means add up, and we've got big square root sign. Okay. Right, so let's focus on this. Let's imagine we've got some data, so I've just made up a couple of numbers. Okay, so here's some data. 3, 6, 9 and 10. And if we want to measure their average, we could take the mean. If we want to measure how spread out they are, we're going to look at this standard deviation for measuring how spread out they are. Okay, so let's find the mean first of all. So if we add them all up, okay, and we divide by how many there are, so that's what, 28 over 4, so that is 7, so the mean is 7. Right, so to get an idea of how far away from the mean they are, we work out the deviation. So that's the bit in the brackets here, that's x minus the mean. So the data number minus the mean, okay, so we call that deviation from the mean. So if we do 3, take away 7, we get minus 4. If we do 6, take away 7, we get minus 1. If we do 6 and 9 take away 7, we get 2, and 10 take away 7, we get 3. So it makes sense as a measure of spread to take the average of those deviations. So let's do that. So we're finding the mean of these deviations from the mean. So we do minus 4 plus minus 1 plus 2 plus 3 and divide by how many there are. Okay, but that will give us 0, and it will always give a 0, because essentially we're doing like the first data point minus the mean, plus the second data point minus the mean, plus the third data point minus the mean, plus the fourth data point minus the mean, and then we divide by how many there are. Okay, now that's the same as getting x1 plus x2 plus x3 plus x4 divided by how many there are, minus 4 lots of the mean divided by how many there are. But when you add the data and divide by 4, that is the mean. And then you're taking away the mean, so you always get 0 if you try finding the average deviation from the mean. So that's why the formula doesn't just have x minus the mean and take an average, add them up, divide by how many there are. Instead, it's got a squared, okay? Because the effect of squaring means we end up with only positive numbers, so it's never going to add up to 0. Okay, so let's just square all the deviations from the mean. So the squared deviations from the mean, so that's going to be 16, 1, 4, and 9. And now if we take the average of zeros, so we've got 16 plus 1 plus 4 plus 9 divided by 4. Okay, and that ends up being 226. No, that's not right. I've typed something wrong there. Okay, so that's 30 divided by 4, which is 7.5. Okay, so this is what we call the variance. So it's the average squared deviation from the mean. So let's look in the formula. Here are the deviations from the mean. With the squared, that's squared deviations from the mean. And then this tells us to add them up and divide by how many there are. So take the average. So inside that square root, we have a variance. Okay. Now the reason we don't just stick with the variance, because that's nice and easy, okay, is because of the squaring. It's messed up the units, and it doesn't make much sense. So if we look here, like the average is 7, If we go 7.5 less than the mean, that would be like minus 0.5, and 7.5 more than it would be like 14.5, which seems far too big, and it's because it's a squared value. So if the data were meters, these deviations from mean would also be meters, but as soon as we square, we're in meters squared. Okay, so that isn't as helpful. It does give us a nice, sensible measure of spread, but it isn't in useful units for us to interpret. So all we do is we square root the variance. So we square root the sum of the average of the square deviances from the mean. Okay, and that gives us the standard, because it's in standard units, standard deviation from the mean. Okay, so here we are, that's the full formula. Deviations just means how far it is from the mean. Okay, we square them to make them more positive. We add them up and divide by how many there are, so we find the average of that. And then we just square it to get sensible units. Okay, it works exactly the same when you have a frequency table. It's just that we use frequencies and midpoints, just a reminder. So if we've got like midpoint and we've got frequency, it could be original values or it could be midpoints from groups. So say we've got 1, 2, 3, and we've got 5, 9, and 4. Okay, then all it means in this case is that you work out what the mean of these is, which would be 2. Okay, and you do the midpoint minus the mean. So we're doing 1 take away 2, which is a nice one. 2 take away 2 is 0. 3 take away 2 is 1. And then our formula tells us to square those. So we square them. Okay, so 1, 0, 1. Alright, then we average them. So in order to average those, when we've got a frequency table, we need to do f times x minus x bar squared, and then we're going to add those up and divide by how many there are. So we're doing 1 times 5, 0 times 9, 4 times 1, add those up, okay, and then divide by how many there are. So 9 divided by the total frequency, which is the sum of the f's. So what's that, 18? So we do 9 divided by 18, which is 0.5. So the variance this time, let's go back to the formula just to see. We do what is the number, okay, what is the mean, how far from the mean is each midpoint or is each number, okay, then we square them, and then we find the average, which means we need to do the frequency times our value, add them up and divide by how many there are, okay, and then at the end you would square root to get from the variance to the standard deviation, okay, but we don't like using this formula because it's a bit of a palaver, as you've seen, especially with the table. And if, for example, we've got one extra person, okay, so we discover that there's another person who got actually 4, then we'd have to start from the very beginning and redo it all, and it's really annoying. Okay, so in the next video I'll explain about the easier to use versions.